Hello and welcome to problem set 21. Our problems today will be from the topic lipids. Before we get started, just a quick reminder that the worksheet to accompany this problem set video is available online through my website. And with that said, let's get started with number 1. Number 1, in nature, the double bonds of unsaturated fats are almost always of the blank geometry. So we're going to fill in the blank. Remember that double bonds can have the orientation that is cis, meaning the larger two groups are on the same side of the double bond, or trans, meaning the larger two groups of the chain are on the opposite sides of the double bond. Fatty acids naturally will have the cis geometry. So the answer to number 1 is that they are almost always cis geometry. Number 2, what chemical reaction results in trans fats in our foods? So remember that trans fats come from the chemical process known as hydrogenation. Those oils are hydrogenated, and through that hydrogenation process, the double bonds get saturated with hydrogen, but not all of them get saturated with hydrogen, and some of them, instead of remaining in the cis geometry, flip into the trans geometry. So trans fats are a byproduct of the hydrogenation process. So that chemical reaction is hydrogenation. Okay, number 3. What functional group forms when a carboxylic acid and an alcohol react under acidic conditions? So an alcohol and a carboxylic acid. In the presence of an acid. Remember that those are going to link together to form an ester functional group, and a byproduct of that reaction will be H2O. Number 4, write out a reaction to show 1-hexanol reacting with pentanoic acid in the presence of an acid catalyst. So we're going to show a specific reaction for that generic reaction we just talked about in number 3. So the alcohol we're going to use is 1-hexanol. So hexane, hopefully you remember, hex is 6 carbons, and hexanol with the OL ending means that it has an alcohol functional group. Well, where's the alcohol? Because we're given the number 1-hexanol, we know that it's at the terminal carbon, at the 1 position. Okay, so 1, 2, 3, 4, 5, 6. And then you can put the alcohol either here or here. Remember, you're drawing the same thing, you're just drawing it backwards. So I'm going to go ahead and put it here. And then these are all hydrogen. Okay, I'm going to leave my hydrogen off just because I'm being a little lazy. All right. That's the alcohol. The carboxylic acid is pentanoic acid. Pentane, hopefully you remember, pent is 5 carbons. The oic acid ending tells you it's the carboxylic acid in this reaction. So let's do 1, 2, 3, 4, 5 carbons for the pentane chain. And then the carboxylic acid, you can put it here or here, it just has to be terminal. It's going to be a carbonyl with an OH. Okay, presence of an acid catalyst. And I'm running out of room, so I'll put our product down here. All right, I'm going to go ahead and draw on my lone pairs. Oh, and let me draw my lines to my hydrogen here. In fact, real quick, I'm going to label these too. So this was our hexanol our 1 hexanol. This was our pentanoic acid. Okay, so our alcohol and our carboxylic acid. So you might already know this is going to form an ester, but what ester is going to form? Well, let's go ahead and use a different color here. Okay, let's use a green pen. So again, just drawing this arrow to help you remember what bond forms and to help you remember what bonds are going to break. Okay, so the oxygen of the alcohol to the carbon of the carbonyl of the carboxylic acid here, that bond is going to form. You're going to lose your OH and your H. There's your H2O. Okay, not a mechanism. Okay, just something to help you remember where the bonds are forming, what bonds are breaking apart, so that you can get the right answer here for your ester. So let's draw our ester here. So it's going to have 6 carbons. Nothing here changed. The only thing that got chopped off here is your hydrogen. So just draw all 6 carbons, 1, 2, 3, 4, 5, and 6, and your oxygen. And I'll go ahead and put my lines to my hydrogen. Okay, now this new bond has formed to the carbonyl carbon. So bond to the carbonyl, and then nothing here changed. So you just draw all that on the side of the carbonyl. So 1, 2, 3, 4, 5. Still 5 carbons there. And all your hydrogen. And don't forget, your byproduct is water. So here's your ester. Okay, you can see your ester linkage here, connecting the 6 carbon chain and that 5 carbon chain. Okay. All right. So that's number 4. Let's go ahead and erase here before we go on to number 5, just so that we have a little more room. Okay, number 5. Lauric acid is the predominant fatty acid in coconut oil. It is a saturated fatty acid with 12 carbons. Answer A through B below. A. Draw lauric acid. Okay, so we're going to draw the fatty acid known as lauric acid. We have all the information that we need given here in the problem. We know that it is a saturated fatty acid, so only carbon-carbon single bonds, and we know that it has 12 carbons. So draw your carboxylic acid. Remember, all fatty acids have a long hydrocarbon tail attached to a carboxylic acid. So draw your carboxylic acid and then 12 carbons. And I'll go ahead and draw it expanded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Always double check it. This carbon counts as part of your 12. The carbon of the carboxylic acid counts as part of your 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Add in your hydrogen, and I'm just going to draw my bonds to hydrogen. Now, if you're doing this on a test and you're trying to do it as fast as possible, you might be thinking, I would much rather draw that in a line structure. So let's go ahead and do that too. So there's your first carbon, the carbon of the carbonyl, that's part of the carboxylic acid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See how fast that is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Always double check. All right. So either one of these answers would be sufficient, since I didn't say in the problem to either draw it expanded or line. So that's why I went ahead and just drew it both ways for you. All right, part B. Draw a triglyceride with lauric acid as its 3 fatty acid chains. Okay, so remember that the triglyceride forms when the glycerol unit, which is the 3-carbon unit with 3 alcohol functional groups, reacts with 3 separate fatty acids. And in this case, we're talking about 3 separate fatty acids of lauric acid. And they form that ester functional group to link them together. So let me draw the glycerol unit. Okay, it would have 3 alcohols. Okay. And these are hydrogens, so just my bonds to hydrogen over here. And each of these is going to react with a carboxylic acid from 3 separate lauric acid chains. All right, so I'm going to erase right there because what we really want to draw here is the triglyceride. So I'm going to go ahead and put my ester linkage. So this oxygen that was part of the alcohol is going to be forming a bond to the carbon of the carbonyl from the carboxylic acid. And I'll draw it expanded first. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Expanded is kind of tiring. Double check it. It's always smart to do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You want to make sure that you're not in such a hurry on a test that you accidentally draw 11 or 13, okay? And then get the problem wrong. All right, 2 more to go. Another ester linkage to your 12 carbon fatty acid chain. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Add in all your hydrogen. It's saturated. And last but not least, our final chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And I always double check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and saturate it. So again, the problem didn't specify expanded or condensed or line structure. And remember, the fastest way to draw these is in a line structure. So let me do that for you really quickly right here. I like to still draw out my glycerol, my 3 carbons here. But you can really save some time on that fatty acid chain. So if you want to do that line structure, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Double check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And another one here. 4, 5, 6, 7, 8, 9, 10, 11, 12. And last but not least, my third. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so a little bit faster to draw it in that line structure. Same answer, just a different format. Expanded and line. Okay, so that takes care of number 5. Let's go ahead and erase here before we go on to number 6. We've got a lot on the board. Number 6. What type of fatty acids contain multiple double bonds? Okay, so we know that there are different types of fatty acids. We know that there are saturated fatty acids, which are saturated with hydrogen, and therefore their hydrocarbon chains contain just carbon-carbon single bonds, like lauric acid in the last problem. And we know that there are unsaturated fatty acids. Those are fatty acids that contain 1 or more carbon-carbon double bond. But we're talking about specifically here fatty acids that contain multiple double bonds. Well, unsaturated fatty acids can be monounsaturated, meaning they contain just 1 carbon-carbon double bond, but they can also be polyunsaturated, meaning that they contain more than 1 carbon-carbon double bond. multiple double bonds. So number 6 is talking about polyunsaturated fatty acids. Fatty acids that have more than one double bond. Let's write that up here. Polyunsaturated fatty acids. Okay. All right, last but not least, number 7. Draw the general structure for a sterol. Okay, so remember, we didn't talk a whole lot about sterols in the tutorial, but one of the things that I did say is important is to be able to recognize the structure of a sterol. And all sterols will have that 4 fused ring structure. They have that in common. So you should be able to draw the 4 fused ring structure. Remember that it's a 6-membered ring connected to another 6-membered ring, connected to a third 6-membered ring, but not consecutively there, it goes up, and finally a 5-membered ring. So 6-membered ring, 6-membered ring, 6-membered ring, 5-membered ring. Now what's hanging off of those 4 fused rings, that will vary, and that will dictate whether or not the sterol is cholesterol or testosterone or a bile acid. So that will vary, but they will have those 4 fused rings in common. All right, that will conclude our problem set 21. I hope that you will consider tuning in to tutorial 22. Thank you very much.